Hello everyone, my name is Zara Khan and my roll number is 225062 and the topic for my presentation is Rolle's theorem. So the statement of Rolle's theorem states that if a function fx defined in a closed interval a comma b satisfies three conditions as stated below, fx is continuous in closed interval a comma b, which means the values of a and b should also be continuous. Fx is differentiable over the open interval a comma b, which means that the curve should be smooth and it should be differentiable between all the values of a and b, but not including a and b. And f of a should be equal to f of b. Then if the three conditions are satisfied, then there exists at least one point C. There may be more than one point, so at least one point, such that A is less than C is less than B, at which f dash C is equal to 0. Now let us see the applicability of Rolle's theorem. So the question is, let fx be continuous in closed interval a comma b and differentiable in open interval a comma b, and fx is equal to small fx minus fa minus f of b minus f of a upon b minus a into x minus a. Test the applicability of Rolle's theorem. So the solution for this will be, since fx is linear combination of fx and x, so fx is continuous and differentiable in open interval a comma b and closed interval a comma b and open interval a comma b respectively. Now let us first check the value of f of a. So this will be f of, in place of x we will put now a, f of a minus f of a minus f of b minus f of a upon b minus a into a minus a. So this will be 0 and this term will become 0 and this term a minus a will also be 0. So we see that f of a comes out to be 0. Similarly, we will find the value of f of b. When we will find the value of f of b, we will put in place of x b. So we will again get the value as 0. So when we conclude, we see that f of a is equal to f of b, which is equal to 0 here. And we see that all the three conditions of Rolle's theorem are satisfied. Hence we say, the Rolle's theorem is applicable. After checking the applicability, we can even find the value of f dash c. We see that there exists one point C which belongs to open interval a comma b, such that f dash c must be equal to 0. Now we will see the value of capital F dash x. This will be f dash x minus 0 bracket minus f of b minus f of a as it is upon b minus a. This will be in square bracket and 1 minus a. Then if we put the value of c in place of x, then we will get f dash c minus f of b minus f of a upon b minus a, and this will be equal to 0, as we know that f dash c is equal to 0. Now when we will equate it, we will get f dash c as f of b minus f of a upon b minus a. So in the conclusion, we have let y be equal to fx be a function which is continuous in a comma b closed intervals and differentiable in a comma b open intervals, such that there exists at least one point c which belongs to a comma b, and f dash c will be equal to f of b minus f of a upon b minus a. Now let us see the geometrical interpretation of Rolle's theorem. Here we see that let fx be a continuous function which possess a graph and f of a is equal to f of b. So this was all about Rolle's theorem. Thank you.